Hello folks, it's me again. Yes, that's right, it's Earl from the LearnAnatomy team. And today we have a very special video. Valentine's Day is coming up, so I thought I'd have a friendly heart-to-heart chat with you. Please excuse the puns, but that's the way that I teach. And we've had a lot of our fans and colleagues writing in and asking us a whole range of interesting questions. And one of the questions that I've been asked to explain is, could I please explain the flow of blood in and through the heart? This is from a student who's currently studying on a massage course and has an exam coming up. So this is one for Leanne. Leanne, I hope you find this video useful. Also want to thank my two sons, Benjamin and Oliver, for providing the introductory music and the closing music on this video. They were really proud of the fact that they're going to be heard, and they're aspiring to one day become famous. So I hope you enjoy both the introduction from Benjamin, my eldest, and the closing from my youngest, who's just had a school play celebrating the Chinese New Year. So, as always, my little friend, Boris Jr. So the heart. The first thing we need to understand about the heart is the language we use to describe the heart. And the little tip, because Valentine's Day is coming up soon, remember the letters C-A-R-D, which spell out the word card. So remember that your Valentine sends you a card on Valentine's Day. Card pertains to the heart, so we know that from cardiac. But also core can pertain to the heart. Coronary, which also pertains to the vessels that supply the heart. So we also know from previous videos that the letters MYO are the prefix for muscle. And I always think of the MY as owning my muscles. So when we put the two together, we can better understand how the heart muscle is made up, called the myocardium. So there we recognize the letters MYO and CARD as well. So what we're saying there is that the heart is a muscle. It is a specific example of involuntary muscle. It has intercalated discs. In other words, the muscle cells fit together to allow the heart to operate as one. And the heart ultimately is a pump. And its job is to receive deoxygenated blood and pump out oxygen-rich blood so that oxygen can be transported around the body to all the tissues to ensure that we maintain and sustain life. So that's the main role of the heart. So where does the heart sit? So if you look at Boris Jr., there's a little space. If we had to cut out the sternum, the heart sits in a space between the two lungs. In fact, the left lung has a little notch called the cardiac notch into which the heart fits. And that's important in terms of the position of the heart. It sits in the chest in an area called the mediastinum. And the heart actually sits in a little bag, in a sense, called the pericardial or pericardium sac. And the heart is ultimately made up of 4 rooms or chambers. So let's start on the right hand side. So as you can see here, we've got a big chamber at the bottom of the heart and a big one on the top. And these 2 major vessels called vena cava return blood from the bottom of the body through the inferior vena cava, and then from the head of the neck and the top part through the superior vena cava. But blood can also be returned to the heart from the heart itself. As you've noticed, the heart has its own blood supply. So that drains into the heart through a little opening called the coronary sinus. So what I want to do now is take you on an inside story so that we can really appreciate the inner workings of the human heart and explore step by step the different rooms, chambers, valves and vessels. So all I've done there, I've opened up the heart. So this is the right side of the heart. So deoxygenated blood, or blood that is rich in CO2 and relatively poor in oxygen, returns to the first room of the heart. And the top 2 rooms are called the atria. Atrium is 1, atria are 2. Think of the room at the top of your house called the atrium. Okay, so these two rooms or chambers receive blood, and the right side is receiving deoxygenated blood. The inner walls of that chamber are quite smooth, and blood fills up this first room on both sides. So remember that these work at the same time, and put pressure on this little valve. Now this little valve between the right atrium and the bottom two rooms, which are called the ventricles. And if we look at the right side, the wall of the right side, the myocardium of the right side, is quite thin compared to the myocardium of the left side, which is relatively thick. Now this little valve on the right side, separating the right atrium from the right ventricle, has got three little cusps. So this valve is called the tricuspid valve. And these little cords that you can see, they are the heartstrings in a sense, and they attach to little muscles. So they are cords that are made of fibrous tendinous tissue. So they are called the chordae tendineae, and they attach to little muscles called the papillary muscles. And when those muscles contract, the valve opens and deoxygenated blood rushes in to fill the right ventricle on the right side. When the right ventricle contracts, it pushes this deoxygenated blood out of the right ventricle in through a little valve over here, and that little valve are moon-shaped or half moon-shaped, so they're called semilunar. And this major vessel is the only artery in the human body that carries deoxygenated blood, and it's called the pulmonary artery, pulmus, pertaining to the lungs. So now the blood is going to go to the lungs so that a process called gaseous exchange can occur, and rich blood in oxygen can return to the left-hand side of the heart. So that little valve, which is half moon-shaped, is called the pulmonary semilunar valve, and deoxygenated blood then goes to the right and left lung, gaseous exchange occurs, and then through four pulmonary veins, the only veins that carry oxygenated blood, that oxygen-rich blood returns now to the left-hand side of the heart, to the top room called the left atrium. It passes through another little valve, but this valve now only has two little cusps, so it's called the meaning two, cuspid valve, or often referred to as the mitral valve. Once again, operates off those heart strings. That blood then fills the left ventricle, and as you can see, the myocardium is thick. This is the septum separating the right and the left. So the pressure is great, and when the left ventricle contracts, it forces blood out through another set of little valves into the major artery that leaves the heart. And this major artery that you can see over here is called the aorta. So these are the aortic semilunar valves, and then the blood travels around the body. So the flow of blood from the left ventricle all the way around the body, returning to the right atrium, is called the systemic circuit, because it's going around the body. The flow of blood from the right ventricle to the left atrium is only going to the lungs, so the circuit is much smaller, so that's called the pulmonary circuit, and that's why the myocardium of the right ventricle is much thinner than the myocardium of the left, because it has a short journey for the blood to travel, so it doesn't need a thick wall. So then the blood circulates, and gaseous exchange, so oxygen moves into the tissue, carbon dioxide and waste products move back into the blood, and the blood is returned once again to the right-hand side of the heart through the vena cava. In another video, we will look at the different vessels, the makeup, and explain to you the difference between arteries and veins, but the request was really trying to better explain the flow of blood through and in the heart. And what we say at the LearnAnatomy team is that the more interactive we can make our learning, the better off you will be able to learn and retain what it is you are learning. So often Jane and myself set up a room, and we get students to walk through the heart so that they can experience what that blood does as it enters each part of the heart. So if you're studying at home, Leanne, Best way to do it, set up your lounge, create the right atrium, the right ventricle, the left atrium, the left ventricle, put little post-it notes in and around each of those rooms, and think about what happens at each, what the pressure's like, because the greatest pressure will actually be in the left ventricle as blood is forced out through the aorta, which then arches as the blood travels around the body. So I hope that's been useful. Have a fantastic Valentine's Day, and I hope you found a heart-to-heart chat entertaining. See you soon from myself, Earl, and my little friend Boris Jr. All the best. Happy studying.